Hi, I'm Pankstein and today I'm going to discuss how the value of Avogadro's number was practically estimated, practically determined. So before that, we must know what Avogadro's number is. So Avogadro's number is the number of atoms in 12 grams of C12 isotope. If you take 12 grams of C12 isotope, sample of C12 isotope, the number of atoms in that 12 gram is equal to the Avogadro's number. So its value is, so also we can define Avogadro's number as it is the number of chemical units. The chemical units may be atoms, ions or molecules in 1 mole of any substance. So that quantity is called as 1 mole. So 1 mole of any substance contains 6.022 into 10 raised to power 23. So most of the students think, contrary to the belief of generation of chemistry students, Avogadro's number was not discovered by Amedeo Avogadro. The first person to estimate the actual number of particles in a given amount of substance was Joseph Lossmith, an Austrian high school teacher who later became a professor at the University of Vienna. In 1865, Lossmith used kinetic molecular theory to estimate the number of particles in 1 cubic centimeter of gas at standard conditions. This quantity is now known as Lossmith constant, and the accepted value of this constant is 2.68 into 10 raised to 18 molecules per cm cube or per liter. Now, the term Avogadro's number was first used by French physicist Jean-Baptiste Perrin. In 1909, Perrin reported an estimate of Avogadro's number based on his work on Brownian motion, the random movement of microscopic particles suspended in liquid or gas. Now we are going to discuss a method by which this value of Avogadro's number practically determined. Now this method involves electrolysis. So first of all, we must know what electrolysis is. If you could see this figure. So electrolysis is just the decomposition of an electrolyte by the passage of electric current through the solution of an electrolyte. Electrolyte is the substance which conducts electricity in its molten state or in its aqueous solution. So when this is electrolytic cell and there are two copper rods, one acts as cathode and one acts as anode. So this is cathode and anode. Okay, so the number of particles in mole of a material is determined by this method. This is called electrolysis. So what happens? Suppose we are supplying electric current. In this electrolysis, what happens actually? Electric current is used to drive a chemical reaction, and that chemical reaction is redox reaction, reduction and oxidation reaction. So when we are passing electric current through the solution of an electrolyte, that electrolyte is dilute H2SO4. So it is dilute H2SO4 solution, and electrodes are copper electrodes. One is anode, one is cathode. So when we supply electric current, electrons, what is current? Current means movement of electrons. So electrons move. Movement of charge creates the current. So electrons are moving, and these moving electrons create the current. So when we supply this electric current, these electrons travel towards this copper cathode. As electrons are coming towards cathode, it acquires a negative charge. So cathode is negatively charged. So now there are lots of electrons on this cathode, copper cathode, and if you consider this solution, solution contains H plus ions as well as sulfate ions, and also we have made this solution in water, aqueous solution. So there are H plus ions as well as OH minus ions. So there are three types of ions: H plus ions, sulfate ions and hydroxide ions. So when electrons, this copper cathode becomes negatively charged, it means it has lots of electrons. So obviously the positively charged ions will get attracted towards this cathode, and when H plus ions come towards this cathode, they gain these electrons to become hydrogen gas. That reaction is shown here. So at cathode, reduction happens. This H plus ions are being reduced to hydrogen gas. Now there is imbalance in the solution. The number of H plus ions and sulfate ions were equal, so there was neutrality of solution. So when H plus ions are converted into H2, so the number of H plus ions has decreased. To compensate that number, what should we do for this compensation of these ions? As H plus ions are decreasing, the negatively charged sulfate ions will obviously increase, so solution is becoming negatively charged. So what happens? These sulfate ions must lose electrons to become neutral, but there are also hydroxide ions. The hydroxide ions may also lose electrons to become neutral. So either sulfate ions will get oxidized, loss of electrons is oxidation, or hydroxide ions will lose electrons, will get oxidized. And there is third possibility, copper from copper anode will lose electrons and jump into the solution. So copper ions will jump into the solution to increase the positive charge, so neutrality will be maintained. Of all these three processes discussed, the process which requires the least energy is that of copper ions jumping into the solution. So that is prepared. Now this copper from copper anode will get oxidized, they will lose electrons, each copper will lose 2 electrons, and these copper ions will get or will jump into the solution. Now this is all what happens in electrolytic cell. Now if you want to determine the Avogadro's number, means we need to determine how many electrons are traveled from cathode to anode and how many moles of electrons are traveled from cathode to anode. So the number of electrons in 1 mole, that is nothing but Avogadro's number. How we calculate Avogadro's number? Avogadro's number is nothing but number of electrons upon the moles of electrons. If you know the number of moles of electrons and number of electrons, you can calculate number of electrons in 1 mole. That is our equation first. Now how you will calculate the number of electrons? So there is equation, Q is equal to Ne. Q is nothing but the quantity of electricity or charge, total charge. And as I have already said that the charge is nothing but, the current is nothing but, electricity is nothing but movement of charge, movement of electrons. So if you know the number of electrons and charge on each electron, you could calculate the total charge. Q is equal to N into E. N is the number of electrons and E is the charge on 1 electron. So from this equation, you could rearrange this equation in such a way that you can calculate the number of electrons is equal to Q upon E. Q is the quantity of electricity, and to calculate the quantity of electricity, you could calculate it by knowing the current flowing for T's time. So T is the time and I is the current. How much current is flowing for how many seconds? So that is IT. So we have got the equation IT upon E, and thanks to Millikan, the charge on electron was discovered by Millikan, and it comes, that equation becomes IT is upon 1.602 into 10 raised to minus 19. This is our equation third. So now we have calculated the number of electrons by using this equation. Now we are going to calculate the number of moles of electrons. So thanks to Michael Faraday, who calculated the charge on 1 mole of electrons. So charge on 1 mole of electrons is 96500 coulombs. So 96500 coulomb means 1 mole of electrons. So if you know the Q quantity of coulomb, you don't know, but Q coulombs will be equal to how many moles? So by the law of 3, you can calculate number of moles of electrons is equal to Q upon 96500. And again, Q can be calculated by the formula IT upon 96500. So number of moles of electrons is equal to IT upon 96500. So now we have got two equations. One is number of electrons, one is of number of electrons, and another is number of moles of electrons. Now substitute these equations, values of these equations, put the values of equation third and fourth in the equation first. Our equation first was number of electrons upon number of moles of electrons. So just by rearranging this equation we get final equation 96500 upon 1.602 into 10 raised to minus 19, and 96500 means charge on a mole of electrons and upon charge of 1 electron. So if you calculate this, the value comes, that value is 6.022 into 10 raised to 23. That is nothing but our Avogadro's number. So this was the method that was used to practically determine Avogadro's number. Thank you.